Okay, good evening children. So continuing with hybridization, sp2 hybridization. So let us take up this molecule CH2 double bond CH2. So we are going to see here is that the carbon atom here is sp2 hybridized. This carbon atom is sp2 hybridized. So let us see how it happens. So carbon electronic configuration 1s2, 2s2, 2px1, 2py1, 2pz0. So excited state, this is ground state, minimum energy state, and the excited state, what happens is this electron goes here. So we have 2s1, 2px1, 2py1, 2pz1. So these are the outermost shell. These only are required to us, they are not needed. Now here in this molecule, it is this atoms, this orbitals which will mix. So 2s orbital will be mixing px, will be mixing py, will be mixing pz, will not be mixing it. So on mixing, three orbitals are mixing and they will form three new orbitals. And the angle between these three new orbitals will be 120 degrees, so that stability is maximum. So those three orbitals, I am drawing. The carbon atom. So this is the hybrid orbital that will form by mixing these three, and it will be called as sp2 hybrid. This is another sp2 hybrid. This is another sp2 hybrid. So sp2, sp2, sp2. And same way on another carbon atom also it is like this. So sp2, sp2, sp2. Now what happens to this pz which has not taken part in hybridization? It will be, we need to show this also, which has not taken part in hybridization, and that pz, it will be, this pz orbital will be perpendicular to this plane. Like all these orbitals are planar, and pz will be perpendicular to this plane. So now since I cannot draw it here, I cannot draw it in front of the board, this pz. So this is the way we show the pz with broken line. Let me draw this at this side. So this is pz. You see pz, it is not hybridized. And another pz that we will be drawing, it will be there. So this is pz. So this pz we have drawn, and now what happens is this sp2 will overlap with 1s of hydrogen. Hydrogen is the surrounding atom. The bond will form sigma bond between carbon and hydrogen. That let me show it here. Sigma bond between carbon and hydrogen. Similarly, this one will overlap with 1s of hydrogen. So similarly, a sigma bond is formed. Same with this carbon, it will overlap with one s of hydrogen. So sigma bond with hydrogen is formed. This also forms a sigma bond with hydrogen. And you see already a bond is formed between carbon and carbon. This is sp2 sigma. And now this pz will be parallel to one another, and they are not so far, they are close, and they will overlap sidewise. And that sidewise overlap, we show it like this. Sidewise overlap, and this results in formation of a pi bond. So this is this molecule, ethene, and now this molecule is planar. This molecule is planar. The bond angle is 120 degree. All these angles are 120 degree. It is planar. So here the carbon atom is sp2 hybridized. So there are many molecules where sp2 hybridization take place in this way. I am telling you a molecule, you should practice yourself. Say BF3. BF3, you will see boron atom will be likewise sp2 hybridized, and each shape will be triangular planar. Okay, now coming to another hybridization, we had done sp3, we had done sp2. Let us take up the case of sp hybridization. sp hybridization, and the molecule where this hybridization is takes place, it is CH, triple bond CH. So this is acetylene, also known as ethyne. So here it is sp hybridized. Let us try to see how it happens. So once again we will take carbon atom in the ground state, we take carbon atom in the excited state. Now here in this case, what happens is, unlike the previous case, what happens is only the S and PX are involved in mixing. PY and PZ doesn't take part in mixing, doesn't take part in hybridization. The S and PX will mix, so this is not taking part in mixing now. So S and PX, these two only are mixing, and so two orbitals mixing will result in two hybrid orbitals. So those two hybrid orbitals, I am showing it here. S orbital, PX mixing to form two hybrid orbitals, two new orbitals, and the angle between them naturally will be 180 degree. So here it is. So this is one sp, and another sp is this one. The angle between them is 180 degree. So this is about one carbon atom, and of another carbon atom, here there are two carbon atoms. So this thing, this is one sp, and this one is another sp. Okay, so we have already done this one. So this is carbon atom sp hybridized. This is also carbon atom sp hybridized. Now let us draw now the py and pz which has not taken part in mixing. So suppose this one is one. So this one is py. this one is PZ. Same way here also. This one is PY. And this one is PZ. So what will happen is this one will overlap with hydrogen. So one carbon hydrogen bond is formed, carbon hydrogen bond. This one will overlap with one s of hydrogen. Another carbon hydrogen bond is formed. Carbon carbon bond is formed. This is sp sigma bond. And this one will be one pi bond. Lateral overlap of py and py, and lateral overlap of, in this way, this one, it was pz. So lateral overlap of pz and pz will result in another pi bond. So this is how in between carbon and carbon there is triple bond formation, and out of these three bonds, one is sigma bond and the two are pi, and the shape of this molecule, since it is all in a line, all atoms are in a line, so it will be linear, shape will be linear. So in ethyne, in acetylene, carbon atom is sp hybridized and its shape is linear. So now let us take up the case of sp3 dehybridization. PCl5 molecule. We see here that in PCl5, central phosphorus atom is sp3 hybridized. So how? Let us do it. First of all, phosphorus has atom number 16. Not 16, it is 15. So its electronic configuration is 1s2, 2s2, 2p6, 3s2, and 3px1, 3py1, 3pz1 according to Hunt's rule of maximum multiplicity. So here you see we need 5 bonds, but we have only 3 half-fill orbitals. So we have to do excitation. So phosphorus in excited state. So we have to take phosphorus in excited state. Now let me show this one in terms of box. 3s, there are 2 electrons, 3p. There is 3 electron. Now phosphorus, is an element of third period. Phosphorus has got 3d orbital is there. No electron is there, but 3d orbital is there. So we can empty 3d is there. We can show this one. 1, 2, 3, 4, 5. So this is phosphorus in the ground state, and in the excited state, what will happen is this electron from here it will go here. It will go to one of the d orbital. I am telling it here only. It goes to dz square. There are dxy here, dyz, dzx, dx square minus y square, dz square. It goes to dz square. You try to find out the reason. I will tell you if you cannot afterwards. So excited state configuration will be now you see we have got 5 half-fill orbitals. So this orbitals is going to mix with one another, So hybridization will take place and it will be sp3d hybridization. sp3d hybridization, and on their mixing, a set of 5 new orbitals will be formed. A set of 5 new orbitals, and now what is the angle between these 5 orbitals? That we have to see. The angle between these 5 hybrid orbitals will be like this. Suppose first of all, let me draw a equilateral triangle. And say this is the center, and now out of 5 hybrid orbitals, 3 will be in the plane of the triangle. Now for simplicity, I am not drawing there the smaller lobe. It is understood that smaller lobe is there. So this is another hybrid. It will be sp3d. This is sp3d. This is also sp3d. So all these are lying on the plane of the triangle. And another 2, will be perpendicular to this triangle above, and another perpendicular to it below. So that above one, it is like this, say, and the one that is below, I am drawing it like this. So these are the 5 sp3 hybrid: sp3d, 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 and now they will overlap with chlorine. Surrounding atom is chlorine, and let us write the configuration of chlorine also. Chlorine is 17. Chlorine will be 17. You can make it out from here. It will be 3s2, 3px2, 3py2, 3pz1 in chlorine. So in chlorine, 1 hybrid orbital, so they will overlap with 3pz of chlorine. So I am showing the overlap here. This is 3pz of chlorine. This is a 3pz of chlorine. This is a 3pz of chlorine. This is a 3pz of chlorine. This is 3pz of chlorine. So PCl5 molecule is formed, and its shape, will be trigonal bipyramidal. Trigonal bipyramidal with equatorial angle 120 degree, and axial angle 90 degree. Equatorial angle 120 degree, axial angle 90 degree. So we can say that in PCl5, phosphorus atom is sp3d hybridized, and its shape is trigonal bipyramidal. So in this way, like in class 12 also, you will see that there will be many cases of hybridization that we have to do. Okay, now in the end, I would like to show you what is positive overlap, what is negative overlap, what is zero overlap. That I am going to show you, and then we will be ending it. Okay. Okay, so you should have some idea about this different types of overlap. What is positive overlap? You see, this is 2p orbital overlapping, and this is an illustration of positive overlap. A p orbital has 2 lobes, and one lobe will be plus, the other lobe will be minus. This plus and minus are not the charge; they are due to sign of the wave function. This is positive, this is negative. So So you see here p orbitals are overlapping positive region, overlapping with positive region. This is called positive overlap. Here you see p orbital is overlapping with s orbital. This is also positive overlap. You see here p orbital, say this is pz overlapping with another pz. It is also a case of positive overlap. Positive overlap. What is negative overlap? Negative overlap means suppose this is a p x and this is also a px, and what has happened here, you see a positive lobe has overlap with negative lobe, then this is called negative overlap. This is also a negative overlap. And what is zero overlap? Okay, this is a case of zero overlap. This is a case of zero overlap. So here you see a s orbital is overlapping, say, with px in this fashion. So this part, is positive overlap. This part is negative overlap. So ultimately, it will be zero overlap. And it is also a case of zero overlap because this is py, this is pz, and py cannot overlap with pz because they are in different directions. So this is also overlap of, the case of py with pz, it is also a case of zero overlap. So children, this much will be coming for your half-year examination. Okay, and there are some portion of chemical bonding left that will be doing after the half-year examination. Till then, good night.